Give me a sec. So guys, with this assignment, all right, I'm going to do an example problem first that goes right from our notes that I'm going to have, and I'm going to work it out for you guys. So once you get something like this, okay, and we know that you have Ohm's law in our triangle, that the voltage is equal to the current times the resistor or resistance values, then that the total voltage is equal to the voltage drop across each resistor. The total current is equal to the current going through at any single point. They're all equal to each other. And then the total resistance is just the added value of all the resistors in the circuit itself. So once you get this, what I would say to do is to draw in, we would make a table, V, I, R, and however many resistors we have. In this case, we have 1, 2, and 3. So to the left of V, I would go like this. I would go 1, 2, 3, and then we need one more for total. We need one more for the total. So we're going to call that RT. And then just making some little lines here for our values. So what you got to do is you got to fill in all your given information. The only given information we're given are the resistor values, right? R1 is 50 ohms, R2 is 100 ohms, and R3 is also 100 ohms. Okay, so what else are we given? We're given the battery of 12 volts. All right, so whenever you get the battery or given the battery, guys, that is your total voltage. So in this case, we got 12. All right, and now we have to figure out the current, the total current, the current going through resistor 1, 2, and 3, and the voltage drops across resistors 1, 2, and 3, plus the total resistance. So, dang, how do we do that? Well, total resistance is equal to all your resistors added together. So since we have those three, you're going to add those three values together. So 50 plus 100 plus 100 is going to equal 250 ohms. That number is your total resistance, this 250. So we're going to put it down here. Now, what we have next, or what we got to do next, is figure out something here. I don't know what else we can do, right? To use Ohm's law, you need 2 out of the 3 variables. So in our table, which row has 2 of the 3? That would be row T. In row T, we have 12 volts, we have 250 ohms. So we can figure out IT using Ohm's law. What is IT? If you cover up I in the triangle, that's going to tell us we're going to do the total voltage divided by the total resistance. So you're going to do 12 volts divided by 250 ohms. Throw that into the calculator, and you get a current of 0.048 amps. So I can now take this value for total current and put it in the IT spot. Okay, so we have 0.048. Now, what's cool about series circuits, or what makes them awesome and easy, is that once you know what the current is at any given position, they're the same everywhere else. So now, what? 0.048, 0.048, and 0.048. Boom, shaka laka laka. So what the heck are the V1, V2, V3? So how you would want to basically, I'm going to oversimplify this, but if you're given, right, this, you're starting off with 12 volts, average, every single time you're going through a resistor, you're going to wind up using up some of your voltage. And you have to use exactly that amount. You can't use any more, any less. It's just a rule. So as you go through one of these resistors, you're going to lose some voltage. You go through here, you're going to lose some voltage. You go through the third one, you should finish and use up all of your voltage. So that's why we're calling them voltage drops. Question.
So wouldn't you do 12 divided by the 3 sides? So it would be 12 divided by 3?
No, because the values here are different. So think about it like this, right? If you're going around and each one of these are like different tolls that you would have to pay, right? Like going through this toll only costs you 50 cents. Going through this toll costs you $1. Going through this one is $1. So they're not going to be the exact same values. So you can't just say divide by 3. So to find the specific drops, to find V1, if I wanted that, V1.
And do you go clockwise or counterclockwise for this?
Depends, but just follow like the R's, right? If R1 goes first, R2, R3, just follow it. So, guys, very, very simply, again, once you have 2 of the 3 variables, you can use Ohm's law to finish the third. So to find V, if you cover up V in the triangle, guys, what is it? I times R, right? But we got to use I1 and R1. So V1 is going to equal I1 times R1. We're going to do 0.048 times 50. This comes out to be 2.4 volts. Cool. Now we're going to do V2. Now notice I didn't put this 2.4 in this position here yet. And I'll tell you why in a second. I1 or V2 is going to equal I2 times R2. So again, current is this 0.048. This resistor for R2 is 100 ohms. So we're going to get 4.8. And then V3, since it's the same one as V2, or the same values, definitely should come out to be the same number. If it's not, we messed up on a calculation somewhere. So remember, like I said, when we go through this circuit, you have to basically use up all that voltage. You can't use any less, you can't use any more. It's got to be 12 exactly. So before I enter these guys into my table, I need to make sure that these add up to equal 12. And it actually does exactly. All right, so 12.0 volts. If that's the case, I'm going to give myself a little check mark, and then I can punch them into their right spots. To this 2.4 volts, the 4.8, and the 4.8. If it didn't match out to be 12, if it was something a little bit extra, or something a little bit below, you would then need to kind of round these dudes a little bit until everything matched up evenly. All right, so finish writing that out real quick. Thanks, sir.
Here.
Okay, we guys got that? Oops. So number 1 on your series circuit assignment, it's already kind of worked out for you, but I'm going to just redo it real quick so you can see it again on how to do these kinds of a problem. So I'm going to just redraw it out, and then we'll work through it. So you have a 12-volt battery connected in series with 3 resistors of these values. All right, so we have 12 volts. So this is pretty much just like the one we did, but there's a little bit of a different piece of information to this guy. All right, so that's what you should have or wound up having in number one. Again, it's already worked out, but how are we going about this? Once you have your circuit and everything, start your table. Your V, your I, your R, and then how many resistors do we have? We have 1, we've got 2, and we have 3, and then however many you have, then afterwards you need a total. Okay, so we're given the resistor values, the 6.75, the 15.3, the 21.6, and then you add all of them together and you come out with 43.65. So RT is going to equal R1 plus R2 plus R3. So the 6.75 plus the 15.3 plus the 21.6 gives us 43.65. So that's just where it comes from, so you don't freak out. And then the only other thing that we're given is the total voltage. In this case, it is 12. All right, the battery, remember, is the total voltage. So 12 volts here. Awesome sauce. Well, we can only use Ohm's law on one of these pieces of information right now. Which would that be? IT. IT, because we have VT and RT. So if you cover up I in the triangle, it would be V over R, or VT over RT. So you would do 12 divided by this 43.65. That comes out to be 0.2749 amps. 0.2749 amps. Now, again, once you know it at one spot, what's good with current? It's the same every single position. So you have 0.2749 here, 0.2749 here, 0.2749 here. So once you figure it out at one position, it's the same everywhere else, which is great. Now we should be able to figure out our V's, our V1, V2, V3. So V1 is equal to I1 times R1. V2 is equal to I2 times R2. And V3 is going to equal to I3 times R3. And now let's put the numbers in. 0.2749 times 6.75. and we come out with 1.855 here. 1 point. Actually, let's see this. All right, so if this is what it comes out to be, this we got 0.2749 times our 6.75, right? This is basically, it comes out to be like 1.855575. I'm chopping it off right here at this 3 decimals for a reason, because when we go through and complete these, all right, you're going to get different values. Now you'll see that not every single time, like in the first problem where when we did this, they added up evenly, perfectly to the battery total voltage. Sometimes they're not going to do that. And this is one of those cases. As we multiply these dudes out, we get something like this. So I add all these guys together, and I get 11.998. This does not equal 12, our total voltage. So we got to round these guys a little bit different. And you might have to play around with them a little bit. And I would say round them, go try and take, once you get like these, round down to like 2 decimals. So then it's easier to maneuver. So like if I did this, right, like it's 1.855, 5 round up here, I can make it 1.86. This one, the 6 could make this a 1, and if I did that, you would see at the very end, right, like it would wind up being over by 0.1, and then I would have to change 1. But let's just say we do this. We're going to make it 4.20, and then this one we round it up to be 5.94. Now, if you add these guys together, those equal 12. And that's the one we're going to use then. We're going to use those values to punch in here. So V1 should then be 1.86. Now, if you made it 1.85 and then this one 4.21, that would work as well. So they should be very, very, very close to the actuals. And 5.94. Okay, guys, number 2, super easy. So I'm gonna, just because I don't want to make sure, I want to make sure that we get enough time to go through number 4 together. All right, I'm gonna skip over number 2 for now. You guys, there is a solution to that on the assignment itself if you watch through the video. So we're gonna go through number 3 next. So this would be our number 3 on our assignment. I'm just going to draw that out for us real quick. You got 9 volts. You have R1. And R2. So R1 in number 3 was this 7.25 ohms, and R2 was this 4.03 ohms. Okay, so this is everything that we're given. So we have our voltage, we have our current, we have our resistors, or resistance. How many resistors do I have? I only have 1, and so I have 2. So then on the left of V, right, I would put, this is for resistor 1, and this is for resistor 2. Now, in the 2 problems that we've done previously, we've had like 1, 2, 3, and then T. That's because we've had 3 resistors in each of those problems. Right now, we don't have a third resistor, so we're just going to have our total. Okay, and then start to fill in everything that you have. You're given R1 of 7.25 volts, R2 of 4.03 volts. The only other thing you're given is the total voltage, which is the battery, of 9 volts. Oh, crap. Sorry, these aren't voltage. These are ohms. That was my mistake there. Okay, so again, you can figure out what the total resistance is by doing what? Adding up all the resistors that you have. All right, so if you do that, you have your 7.25 plus your 4.03, and you're going to get an RT value of 11.28 ohms. So once I know that, I can put it down here, this 11.28 ohms. All right, beautiful. Now I can do Ohm's law to find IT. I'm going to do 9 over 11.28. And that kicks out like 0.798. So for this, I'm actually going to round this current, guys. I'm going to round this one to 0.8. Yeah, I'm going to call this 0.8.
1.81.
Nah, I'm going to just call it 0.80 amps as my IT. And a total current. So with that, again, in series, the current at any spot is always the same. So if you know what the total is, that's the same current going through resistor 1 and going through resistor 2. Now we have to find our voltage drops. So V1 is going to equal I1 times R1. V2 is going to equal I2 times R2. So 0.8 times 7.25. That comes out to give me 5.8. And this comes out to be 3.22. Okay. Now remember, your voltage drops have to add up together and equal the total. What's the total? 9. So when I add these two together, I need to get 9 exactly. No more, no less. But there's a problem. Yeah, I got 0.902. So something's off. So let's round. What should I change, or what could I do?
You could round 22 to 0.2.
Yep, good. Round the 322 to just 0.2. So basically get rid of that, John. And if I did that, add them up, and we're going to get 9 exactly. So that means we're using these values here, this 5.8 and this 3.2 as our guys in our table. Very good. Okay, and then the reason why I wanted to get to this one, all right, and made sure that we had enough time is because number 4 is different from the 3 that you've seen. Number 2 is just like now, very, very similar to the 3 that we have done. Okay, one on this assignment, the example problem, and number 3 on the assignment. But number 4 is drawn a little bit differently. Number 4 says that you have a battery of 4.5 volts. And you have a resistor of 7 ohms that is in series with a second resistor, but we don't know what that value is. And the only other piece of information that they give us is that we have an ammeter that tells us the current in the circuit is 0.6 amps. So when you see this symbol, this is going to tell you the current running through a specific point in the series or in a circuit. Now for a series circuit, current is the same everywhere. So for this problem, same thing we do, as always, we're going to have our V, our I, and our R. How many resistors do we have in total?
Two.
Two. So we're going to have 1, 2, and T. All right, let's fill in everything that we can. What's our total voltage? Whatever the battery is.
4.5.
And that is, yep, 4.5 volts. What is R1?
7.
Good. 7 ohms. R2, well, we don't know that. And so then we can't do RT. So crap. The hell do we do? Well, see this 0.6 here?
Mm-hmm.
Guess what? That's your total current. And not only is it your total current, that's your current everywhere.
Question.
Okay, question?
So, can there be, by any chance, instead of the total V, can there be like two V's? Like on the box?
2 batteries?
Yeah.
There could be, but we're not going to go through those kinds. That's not backflashing. All right, so guys, again, what do I do? What do I do here? Well, you pretty much need to know one of these other resistor values.
V over I, correct?
Well, can I find RT?
Yes.
I could. So let's do that. If I go to find the total resistance, because I have 2 of those values, in the triangle, if I cover up R, it's going to be the total voltage over the total current. So 4.5 over that 0.6. And when you do that, you're going to get an answer of 7.5 ohms. So that is my RT. Now,
It's 7.
say it.
7.
Good. R2 should be what? 0.5. How'd you figure that? Well, we know what the total should be. The total is 7.5, and we know one of them. And from our rule before, right, the total resistance in a series circuit is you add all the resistors together. So 7 plus something has to equal 7.5, which means, yeah, R2 needs to be, all right, 0.5 ohms. And now you can find your V1s and your V2s. Oop, I1 times R1 and I2 times R2. D2. And it just plug them in. So we're going to have 0.6 times 7. If we do that, that gives us
4.2.
thank you, 4.2. And then our 0.6 times 0.5 is going to give us 0.3.
Yep.
Okay, so those are our voltages, our voltage drops. So we got to make sure they add up to equal the total, which they add up to equal to 4.5. Bingo. So these are our numbers that we need, the 4.2 volts and the 0.3 volts. Boom. Now, could I have done this a slightly different way? You could have. I don't want to confuse you, but just saying, because all right, these things were blank.
I'll go with your buddy.
YouTube up.
I gotta go get.
Yep. Because these things were blank, right? I could have, since I had, or these were the blank pieces of information, and we decided to use RT here. I could have found V1 first, this times this, and I would have gotten 4.2. And then what I could have done is I could have subtracted 4.5 minus 4.2 and gotten this as 0.3, and then done multiply these two together to get my 0.5. So just look, in that case, there is another way to do it. But I think
an opposite way.
yeah, it's just kind of doing it the retro version of it. So you guys are going to wind up finishing number 2.
Is there any more like ones that are different length for?
So there will be a couple other ones like number 4, number 8 is similar to that, but for us guys, I only want us to complete 1 through 4 today. All right. Monday we'll complete the others. So all you guys have to do tonight is do 1 through 4. We just did 4, so you guys can do number 2. Number 2 is just like the first 3 that we did, and there's really not going to be any rounding, I don't think, to worry about. So you guys should be able to bang that one out pretty quickly. Okay. And again, also, if you have the Google Doc up, I have a walkthrough solution, just like a video. All right. That will take you through it step by step if needed. So there's no excuse not to get any of the homework done right now.